Hey everyone, and welcome. Today, we're jumping into a book that's pretty much a legend in the machine learning world, Hands-on Machine Learning. We're going to break down its core ideas and get a real practical look at how these incredible intelligent systems actually get built from the ground up.
You hear about AI everywhere, right? It's changing everything. But it makes you wonder, what does it really take to build one? Is it some kind of secret digital magic that only a handful of people know how to do?
Well, the book lays it out right from the start. Building AI isn't really about searching for some single magical algorithm that solves everything. Nope, it's much more like a journey, a hands-on, step-by-step quest. So let's start this quest. Every great adventure needs a map and a destination. In machine learning, that first big step is what we call framing the problem. It's all about figuring out exactly what you're trying to do before you even think about writing code. And to make this super clear, we're going to follow the classic example from the book. Our mission, our quest, is to build a system that can predict the median house value for any district in California. See? A nice, clear, tangible goal.
Okay, so we've got our goal. Where do we go from here? You might think it's time for some fancy, complex models, but not yet. We start with the raw material of everything in AI, the data. This is the foundation, and honestly, it's where something like 80% of the real work happens.
And here's something that might surprise you. There's this famous idea in the field that for really complex problems, having more good data is often way more powerful than having a fancier algorithm. It's true. In this world, data is absolutely king. This quote from some Microsoft researchers back in 2001 really nails it. It basically says, hey, maybe we should think about where we're spending our time and money. Is it on tweaking algorithms or on getting more and better data? More often than not, the smart money is on the data. But here's the catch. Getting good data is not easy. It really is like trying to survive out in the wilderness. You run into all kinds of trouble. Maybe you don't have enough data, or the data you have is biased and doesn't really represent the real world, or it's just messy, full of mistakes and weird outliers, or the features you have are just totally irrelevant. And this is where the real artistry of machine learning comes in. It's a creative process called feature engineering. It's all about taking the data you have and cleverly combining or transforming it to create new signals that are way more predictive. So let's go back to our housing problem. You might start with data points like total rooms and total bedrooms. And they're okay, but check this out. What if we engineer a new feature by dividing bedrooms by rooms to get a bedrooms ratio? All of a sudden, you have something that's a much, much better clue about a house's value. That's feature engineering right there. All right, so our data is looking good. We've even crafted some powerful new features. Now it's finally time to get to the part everyone talks about, forging the actual model. This is where we pick our tools to start making predictions. And this is the question on everybody's mind, right? You look out there and there are literally hundreds of different algorithms. Linear regression, random forests, neural networks. So which one is the best? There has to be a best one, doesn't there? Well, this brings us to a really important idea in machine learning called the no free lunch theorem. And what it says is there's no silver bullet. No single model is guaranteed to be the best for every problem you encounter. The only way to really know what works for your project is to just roll up your sleeves and try a few of them. So what do people even mean when they say they're training a model? It sounds pretty complicated, but the core idea is simple. It's basically a process where an algorithm adjusts the model's internal settings, you can think of them like a bunch of little dials and knobs, over and over again until it gets as good as possible at making correct predictions on the data you've shown it. But be careful, because this whole training process has a dark side. There's a really common trap on this quest, a monster that every single machine learning practitioner has to learn how to fight, and its name is overfitting. So what is overfitting? It's what happens when your model gets too good at understanding the data you trained it on. It gets so obsessed with the details that it starts to memorize all the random noise and flukes in your specific dataset instead of learning the actual underlying pattern. And the result? It performs terribly when it sees brand new data it's never encountered before. This visual explains it perfectly. On the left, you've got a good model. See how it captures the general trend? It's learned the pattern. But on the right, that's an overfitted model. It's twisting and turning like crazy just to hit every single data point perfectly. It hasn't learned, it's just memorized. And that makes it totally useless for predicting the future. So, how do we slay this beast? The book gives us 3 main weapons for our arsenal. First, you can just use a simpler model, one with fewer of those dials and knobs to get confused by. Second, you can go out and get more training data, so it sees more examples. Or third, you can go back to your data and try to clean out some of that noise and fix the errors. Okay, we've framed our problem, we've tamed our data, we've forged a model, and we've learned how to avoid the trap of overfitting. We're at the final trial of our quest, launching our system into the real world so we can actually start doing something useful. And you know what? The path to getting it live is actually way more straightforward than you might think. Once you're happy with your model, you literally just save it as a file. It's just like saving a Word document. Then you take that one file and you deploy it. And a super common way to do that is to wrap it in a web service. Now, some other app, like a real estate website, for example, can send it new information about a house, and your model will instantly send back a price prediction. And just like that, it's live. It's out there in the world doing its job. But here's the final lesson. The quest never really truly ends. Building these systems is a circle. Once your model is out there, you have to watch it. You have to maintain it. And because the world is always changing, pretty soon the quest to build an even better, smarter model starts all over again.
So we've gone through the whole journey, from asking a simple question all the way to a live system making real predictions. Now that you've seen the map, it makes you think, doesn't it? What problem out there would you pick for your quest?